When we look up at the night sky, something curious happens. We know, at least rationally, that we're observing stars. We know they aren't small points stuck to a dark dome, but enormous suns, incredibly far away, burning in space. And yet, our brain insists on something else. We see them together, close, as if they were placed on purpose, forming drawings, lines, recognizable figures. Orion, the Big Dipper, the Southern Cross, constellations that look like maps, paths, stories drawn upon the sky. But that feeling of closeness is a deep illusion, one of the most persistent ones we've carried as a species. Christophe Galfard explains that the night sky is, in reality, a great visual deception, not because it's maliciously lying to us, but because our senses aren't prepared to understand the universe's true scale. The stars we see aligned are not aligned. The ones that appear to be neighbors don't know each other. Some are relatively close, others are thousands of times further away, but the light flattens them onto the same apparent surface. It's like looking at a photograph. Everything appears to be on the same plane, even though we know there is depth in reality. Our brain is designed to survive at short distances, a few meters, maybe a few kilometers. Even when we think of long journeys, we still speak in human terms, hours, days, weeks. But space doesn't work like that. The space between the stars cannot be understood with the mental tools we use to cross a city or travel a country. There are no everyday references. There are no familiar intermediate points. There is, above all, void. And that void is the real protagonist of this story. Kees Boeke, in Cosmic View, proposes a simple but revealing exercise: to step back little by little, to take constant jumps, always multiplying the distance by the same factor. At first, everything seems comprehensible. A room, a house, a city, a country. Then the entire Earth. Next, the moon's orbit. Further out, the solar system. And then something strange happens. At some point in the journey, the objects begin to disappear. Not because they cease to exist, but because the space between them becomes so large that the only thing remaining visible is the nothingness. When we reach the scale of the stars, the void dominates the scene almost completely. Stars don't fill space, they punctuate it. They are luminous exceptions in an ocean of darkness. And the most unsettling thing is that even the star closest to our sun is so far away that the word close loses its usual meaning. Proxima Centauri, the nearest star to us, seems to be right there when we see it named in a book or documentary. But if we try to translate that distance into something human, the effort becomes uncomfortable. It is not enough to say that it is little more than 4 light years away. We must pause there. Breathe. Think about what that really means. A light year is not a unit of time, it is a unit of distance. It is the path light travels in a full year, moving at almost 300,000 kilometers per second, never stopping. And yet, it needs more than 4 years to arrive from that star to us. Galfard insists on something important. It's not that the number is big, it's that it's outside our intuitive range. Saying 4 light years doesn't activate any clear image in our mind. We cannot visualize it. The idea that they could be at almost inconceivable distances seemed unnecessary, even absurd. Why create such a vast universe if almost everything would be empty? That thought was not naive, it was profoundly human. We tend to assume that the world exists on a reasonable scale, proportional to us. We think that reality must make sense from our point of view, but the universe never promised to be comfortable. For centuries, the fact that the distance to the stars could not be measured was interpreted as proof that they were relatively close. If we cannot detect their apparent displacement, their parallax, then perhaps they are not so far away. This conclusion seemed logical, but it was incorrect. The stars did not show parallax not because they were close, but because they were so far away that the Earth's movement around the Sun was insignificant in comparison. Here a key idea appears. The true distance between the stars is not only great, it is so great that it breaks our intuitive methods of measurement. It is not enough to look. It is not enough to compare. It requires patience, instruments, time, and above all, accepting that the universe is not made to our measure. Bokeh uses a powerful visual metaphor. When we take jumps in scale, a moment comes when the universe ceases to seem full. At human scales, there is always something. One house next to another, one street next to another, one city after another. But at the stellar scale, the void is the norm. The stars are rarities, scattered points in an almost infinite expanse of nothingness. And that void is not a mere backdrop. It is a fundamental actor. The space between the stars defines how light moves, how long information takes to travel, why the sky we see is an image of the past. When we observe a star, we don't see it as it is now, but as it was when its light departed. In the case of nearby stars, that difference is small, but even there, we never see the present. We always see a memory. Distance converts the sky into a kind of historical archive. Each luminous point is a time capsule. Some stars we see no longer exist. Others are changing while their image travels toward us. But the space between them is so vast that there is no way to synchronize the now. The universe does not have a single present. Galfard explains that this idea is profoundly counterintuitive. In our daily lives, everything happens more or less at the same time. We talk, we respond, we react. But at the cosmic scale, time stretches just like space. Distance not only separates objects, it separates moments. And here another powerful deception appears: brightness. We tend to think that a bright star is close and a dim one is far away, but that is not necessarily true either. Some stars are incredibly luminous and can be seen from enormous distances. Others are small, faint, and barely shine even if they are relatively close. The sky does not give us clear clues. It shows us beauty, but it hides depth. For thousands of years, humanity built mythologies based on that flat appearance of the sky. Stories of gods, animals, heroes, all of them relied on the idea that the stars formed a shared roof. No one suspected that between one star and another, there could be a distance greater than the one separating millions of imaginary suns. When we finally began to understand these distances, something changed in our relationship with the cosmos. The universe ceased to be a close stage and became an almost unfathomable space. Not bigger in the abstract sense, but emptier, quieter, slower. Bokeh insists that the most difficult conceptual leap is not imagining distant stars, but imagining the space between them. Because space has no texture, no color, no shape. It offers no references. There is no something to help us measure it. It is an absence that stretches for full light years. And yet, it is that absence that makes everything else possible. The void allows stars to exist as separate entities. It allows galaxies not to collapse onto each other. It allows light to travel for millions of years without obstacles. The space between the stars is not a waste. It is an essential condition of the cosmos. when we say that no one understands the true distance between the stars. We are not saying that numbers or data are lacking. The numbers exist. The measurements are precise. What is missing is an emotional translation, a way to feel that distance, because it is not enough to know that something is far away. We have to understand what it means to be far away in a universe where light is the fastest thing that exists, and yet takes years to cross the void. This first block leaves us facing an uncomfortable but fascinating idea. The sky we see is a two-dimensional illusion created by three-dimensional distances so enormous that our brain flattens them to survive. We live under a sky that appears close, but which is really a silent immensity, separated by voids that defy any intuition. And we have barely begun. There is a very specific moment when our mind begins to surrender. It doesn't happen all at once. It's not an immediate explosion of confusion. It's more subtle. At first, we think we understand. We nod. We think we are following the thread. But then, without realizing it, the scale changes and something breaks. We no longer know exactly what we are imagining. We keep listening, we keep reading, we keep looking at images, but the intuition is left behind. That moment marks the limit between the human scale and the cosmic scale. Kay's book constructed cosmic view precisely to bring us to that limit and gently push us a little further, not with overwhelming numbers or formulas, but with something much more powerful: constant jumps, always the same factor, always the same step, a calm progression that nevertheless ends up revealing the immense in an almost uncomfortable way. It all begins with the familiar, a human being standing in a room. Nothing strange. Everything makes sense. We can measure the room with steps, with meters, with body gestures. The room contains recognizable objects: a table, a chair, a window. The space is manageable. Our brain feels comfortable here because it evolved for this range. We are creatures of this scale. Then we take the first jump. We leave the room and see the entire house. It is still comprehensible. A house is simply a room multiplied. More walls, more spaces, but the logic is the same. The second jump takes us to the street, the third to the neighborhood, afterwards to the city. Each step expands the field of vision, but does not break the intuition. We can still imagine it. We can still say, "Yes, I understand." Even when we reach a country or a continent, the mind adapts. We have seen maps. We have traveled. We know there are roads, mountains, rivers. The scale is larger, but it remains human. The entire Earth, seen from space, already starts to feel a little more uncomfortable, but still, it is a known image. A blue sphere, beautiful, finite, encompassed in a single glance. Up to here, everything seems reasonable. But then comes the next jump. The moon's orbit around the Earth does not usually occupy much space in our daily imagination. We think of the moon as something close, almost intimate. We see it every night. But when we place it to scale, when we draw the Earth as a small sphere and the moon orbiting at a proportional distance, something begins to change. The space between them is not full. There is nothing. It is a clean, wide, silent separation. Even so, we can accept it. It's only a few 100,000 kilometers. The mind still copes. The real problem appears when we take the next jump, the solar system. If we represent the sun as a visible sphere, the planets do not cluster around it as we usually see in books. They do not form a compact whole. They are dispersed, separated by enormous voids. Even the inner planets are so far from each other that, at a real scale, They almost disappear from the drawing. Jupiter is so far away that it seems not to belong to the same system. Neptune is practically a rumor in the distance. But even so, we keep thinking, okay, the solar system is big. We keep using the word big as if it still made sense. And then the jump that changes everything occurs. We leave the solar system. This is where the human scale truly breaks. The solar system, with all its impressive size, turns out to be barely a speck in interstellar space. This is not an exaggeration. If we were to draw the solar system on a scale where the sun is a coin, the nearest star would not be on the same sheet of paper, nor in the same room, nor even in the same building. It would be kilometers away. This is the exact moment when the brain begins to fail, because until now, each jump had enlarged something that already existed. A bigger room, a more extensive city, a wider system. But now, we are not enlarging an object. We are enlarging the void. We are saying that between one star and another, there is no something else, but almost nothing for absurdly long distances. Boca insists on this with almost pedagogical clarity. The universe is not full of things. It is full of space. Things are exceptions. Stars are not the norm. They are interruptions. The distance between the Sun and Proxima Centauri is so great that any everyday comparison becomes useless. Saying it is close is a linguistic joke. Saying it is far away doesn't help either, because far away is a word we use for things we can reach with effort. Here, no effort is possible. There is no shortcut. There is no comfortable intermediate scale. So the mind doesn't get lost. Bouquet proposes something fundamental: to maintain the same jump in scale again and again. Do not change the factor. Do not cheat. Always multiply by the same amount. It is an honest way of showing how the universe slowly escapes our comprehension without the need for exaggerations. And that is where we understand something crucial. The problem is not that the universe is big. It is that it grows faster than our intuition. Each jump seems reasonable on its own, but when we chain them together, the result is overwhelming. When we finally place the nearby stars on that mental map, what we see is not a compact network of lights, but a scattered archipelago. Each star is a solitary island. Some are a little closer, others much further away, but none form a dense cluster. There are no stellar streets. There are no neighborhoods. There is solitude. Galfard complements this idea by reminding us of something unsettling. Even when we talk about nearby stars, we are using deceptive language. The nearest star is so far away that if humanity had emerged with the ability to travel at the speed of a modern airplane, it would take us millions of years to arrive, not due to a lack of technology, but because the distance simply does not forgive. Here, another break in scale appears: time. Cosmic distance is not only measured in kilometers or light years, it is measured in patience, in waiting, in duration. Each imaginary journey between stars immediately becomes a temporal question. How long would it take us? How many generations would pass? How many civilizations could arise and disappear in the interval? Bouquet shows that when we scale the universe this way, time begins to stretch just like space. We no longer speak of hours or days, but of centuries, millennia, millions of years. Space imposes its own rhythm, a rhythm so slow that our individual life ceases to be relevant as a unit of measure. And yet, we keep advancing. When we take another jump and observe a volume of space containing several nearby stars, what we see is not a swarm, but a desert dotted with points. Even in dense regions of the stellar neighborhood, separation dominates. The distance between one star and another remains immense compared to the size of the stars themselves. This contrast is brutal. Gigantic stars separated by even more gigantic voids. Our Sun, which seems enormous from Earth, is insignificant compared to the space that surrounds it. It is like a lost spark in an infinite cathedral. It does not fill the space. It barely marks it. This is where the human mind usually plays an unconscious trick. It begins to mentally compress the distances, to pull the stars together, to imagine the universe as something more compact than it really is. It is a cognitive defense mechanism. If we don't do it, the magnitude overwhelms us. But reality does not compress. Bokeh is insistent on this point. There is no correct way to understand the cosmic scale without accepting that our intuition will fail. It is not a personal defect. It is not a lack of intelligence. It is a biological limitation. We evolved to survive in a narrow range of sizes and times. The cosmos has no obligation to adapt to that. When we finally place the Sun and its neighboring stars within the Milky Way, another, even deeper break occurs. Because the galaxy is not simply a cluster of stars. It is a system where the stars are separated by gigantic distances, but they are still organized into a common structure. It is a visual paradox, enormous dispersion and organization at the same time. The Milky Way contains hundreds of billions of stars, but not because they are squeezed together, but because the volume is unimaginably large. It is like a city so vast that each inhabitant lives kilometers from any other, and yet they all form part of the same entity. And when we take the next jump, the one that shows us entire galaxies, the lesson is repeated at an even more extreme level. Galaxies are not close together either. They are separated by voids so large that light takes millions of years to cross them. Again, the pattern is the same. Tiny things separated by colossal spaces. The cosmic scale is not built by accumulating objects. It is built by accumulating void. This is perhaps the most difficult message to accept. We do not live in a universe full of things, but in a universe where things are rare and space is the rule. The distance between the stars is not a technical detail. It is a fundamental characteristic of the cosmos. It defines how matter moves. It defines how light evolves. It defines why the universe is so silent. It defines why contact between civilizations, if they exist, is so improbable. And above all, it defines our real position. Bokeh wanted the reader to feel something upon reaching this point. Not superficial astonishment, but a kind of stillness, a pause. The sensation that we are very far from almost everything. Not only physically, but conceptually. We live on a luminous island, surrounded by an ocean so vast that we can barely imagine its shore. This block does not seek for us to memorize distances. It seeks something deeper, that we accept that our scale is not the scale of the universe, that our usual words, near, far, big, small, lose meaning when we leave home and keep advancing, jump after jump without stopping. For most of human history, the sky was a constant and deceptive presence. Every night, the stars appeared in the same place, with the same arrangement, with an almost reassuring regularity. They did not appear to move among themselves. They did not appear to approach or move away. They gave no clue of depth. It was natural, almost inevitable, to think that they were all more or less at the same distance, embedded in a gigantic sphere that surrounded the Earth. That idea was not born of ignorance, but of direct experience. Our senses offered no reason to think otherwise. Alan Hirschfeld explains that the great problem of stellar distance was not technical at first, but conceptual. Before something can be measured, one must accept that that something can be measured. And for centuries, the very possibility that stars were at enormous distances seemed unnecessary, even uncomfortable. If the universe worked well without that assumption, why introduce it? The sky seemed ordered, finite, stable. There was no urgency to complicate it. Furthermore, there was an even deeper obstacle: movement. If the Earth moved around the Sun, as the heliocentric model proposed, then the stars should show a slight apparent displacement throughout the year. That displacement, called parallax, would be the direct proof of both the Earth's movement and the star's distance. But that displacement was not seen. Year after year, century after century, astronomers looked carefully and found nothing. The stars remained fixed relative to each other, as if they were nailed to the firmament. This fact was used for a long time as a powerful argument against the idea that the Earth moved. If there was no parallax, then either the Earth was stationary or the stars were so far away that their displacement was imperceptible. And this second option seemed absurd. So far as not to move even a little? So far as to defy even the most careful instruments? For many, that was asking too much. Thus was born one of the most persistent, false intuitions in the history of astronomy: that the stars were relatively close. Not close in human terms, but within a reasonable scale. This intuition was not capricious. It was reinforced by everyday experience. When something is very far away, it usually looks small or blurry, but the stars were sharp, well-defined points. They did not seem to blur with distance. They did not seem to lose clarity. This reinforced the idea that they could not be that far away. The problem, as Hirschfeld points out, is that the light from the stars does not behave like terrestrial objects. A star does not reflect light, it produces it. Its brightness does not diminish in the same intuitive way as that of a distant mountain or building. A star can be incredibly far away and still look bright. This simple fact was a cognitive trap for centuries. Another important limit was the human eye itself. Even with rudimentary optical instruments, the necessary precision to detect stellar parallax was far below what could be achieved. The expected displacement was tiny, much smaller than the apparent thickness of a star seen from Earth. It was like trying to measure the width of a hair seen from kilometers away. No matter how much patience the observer had, the limit was not human, but physical. Hirschfeld describes how, for generations, astronomers tried again and again to measure that displacement. They did it with increasingly refined instruments, with more precise rulers, with longer observations, and each time they failed, not because they were wrong in their reasoning, but because the universe was playing in another league. The stars did not resist being measured out of pride. They were simply too far away. This repeated failure had profound consequences. Some astronomers began to doubt the very idea of measuring stellar distances. Others suspected that the method was incorrect. Others, more radical, rejected heliocentrism completely. The debate was not only scientific, it was philosophical. Accepting that the stars were at immense distances implied accepting a universe much bigger, emptier, and less centered on Earth than many were willing to imagine. During this period, numerous errors were committed. Some astronomers believed they had detected parallax where there was none. They published results that were later proven incorrect. Others unconsciously adjusted their data to fit their expectations, not out of dishonesty, but out of an overconfidence in their senses. When one expects to see something, one sometimes believes they see it. Hirschfeld clearly shows that these errors were not shameful failures, but necessary steps. Each failed attempt refined the methods, improved the instruments, and sharpened the understanding of what was truly being sought. Science advanced not despite those errors, but because of them. Another significant obstacle was the very concept of reference. To measure parallax, it was necessary to assume that some stars were so far away that they could be considered fixed, while others, being closer, would shift relative to them. But if the distance to any star was unknown, how could they decide which ones were the distant ones? It was a circular problem. Everything depended on everything else. For a long time, astronomers tried to solve this problem by observing bright stars, assuming they must be close. But many of them turned out to be simply very luminous, not close. This led to erroneous measurements and enormous frustration. The sky seemed to mock those who tried to decipher it. The lack of visible parallax also fueled an unsettling feeling. Perhaps the universe was built in a completely different way than they imagined. Perhaps the stars were not distant suns. Perhaps they were lights attached to a sphere. Perhaps space had no real depth. These ideas seem naive to us today, but for centuries they were reasonable hypotheses based on the available evidence. The great historical problem, then, was not the absence of data, but the tyranny of perception. Our senses were convinced of one thing, and reality insisted on another. But without adequate instruments, there was no way to resolve the conflict. Science was trapped between what it saw and what it suspected. Hirschfeld underscores something fundamental. Measuring the distance to the stars was not just a technical challenge, but an act of humility. It required accepting that our eyes were not reliable arbiters of reality, that what seemed obvious could be profoundly false, that the universe did not have to be intuitive. As centuries progressed, instruments slowly improved. Larger telescopes, more stable mounts, and more precise measurement systems were built. But still, parallax remained elusive. The displacement was so small that it was buried in the noise of the observations, in the vibrations of the instrument, in the imperfections of the glass, and in the turbulence of the air. The sky, moreover, did not help. The Earth's atmosphere distorts the light from stars, making them flicker, move slightly, and change shape. These effects were much greater than the displacement being attempted to be measured. It was like trying to detect the movement of a coin at the bottom of a shaken lake. Each failed attempt reinforced an uncomfortable lesson. The universe was not only vast, it was cruel to our expectations. It offered no shortcuts. It did not allow itself to be easily measured. It rewarded not intuition, but extreme patience. Finally, when parallax was detected conclusively, it did not happen as a spectacular revelation, but as a silent confirmation. The displacement was real, but minuscule, so small that it could only be measured with instruments specifically built for that purpose, with a precision that would have been unthinkable a few decades earlier. And when that displacement was translated into distance, the result was devastating to human intuition. The stars were not far away, they were absurdly far. So far that even the concept of distance seemed to break. That moment marked a turning point. The universe suddenly expanded in the human mind. Not physically, but conceptually. Suddenly, the sky ceased to be a close vault and became an abyss of enormous separations. Earth ceased to occupy a central place and became just another point, orbiting an ordinary star, lost among countless others, all separated by distances that no human journey could cover in one lifetime, nor in 1,000. Hirschfeld makes it clear that this discovery was not immediately celebrated. It was disconcerting, unsettling, even disturbing. Accepting the true distance between the stars meant accepting our smallness, our solitude, our physical disconnection from the rest of the cosmos. It was not a comfortable idea, but it also opened a door. Because once we accept that the stars are truly that far away, everything else makes sense. The brightness, the silence, the stability of the sky, the slowness of the changes. Everything fits. The universe is not deceptive. We are the ones who expected too much from our senses. This block leaves us facing a powerful conclusion. For most of our history, we did not understand the true distance between the stars, not because data was lacking, but because our minds resisted accepting it. The problem was not the sky, but our expectations. And now that we have learned to measure that distance, the challenge is no longer technical. It is emotional. It is learning to live with the idea of a universe that is immense, silent, and profoundly foreign to our everyday scale. Imagine extending your arm in front of your face and raising one finger. Close one eye, then close the other. The finger seems to move, even though you know perfectly well that it hasn't shifted a millimeter. That small, apparent, almost insignificant jump is something we have all experienced without giving it much thought. However, hidden within that everyday gesture is one of the most powerful ideas in the history of science. An idea so simple that it went unnoticed for centuries, and so delicate that it took entire generations to be harnessed correctly. That apparent shift is called parallax. It is not a visual trick or an illusion. It is a direct consequence of observing an object from two different positions. The closer the object is, the greater the jump. The further away, the smaller. And when something is extremely far away, the displacement becomes almost impossible to detect. For centuries, astronomers understood the concept of parallax on Earth, but failed to apply it to the sky. They knew, in theory, that if the Earth moved around the Sun, the stars should be seen from slightly different angles at different times of the year. The Earth's orbit offered an enormous baseline for observation, hundreds of millions of kilometers from one end to the other. If no displacement was detected, even so, there were only two possibilities. Either the Earth was not moving, or the stars were at such colossal distances that even that baseline was insignificant. For a long time, this second option seemed exaggerated. Not because it was impossible, but because it was profoundly unnatural for the human mind. Accepting it meant admitting that the universe was much, much larger than anyone had imagined, and that almost all of that size was occupied by nothingness. It was neither a comfortable, nor an aesthetic, nor an intuitive conclusion. So parallax became a kind of scientific ghost. Everyone talked about it. Everyone searched for it. No one could catch it. Alan Hirschfeld describes this period as a long wait, fraught with frustration. Meticulous, patient, even obsessive astronomers dedicated years of their lives to measuring stellar positions with extreme precision. They observed the same stars night after night, month after month, year after year. They recorded every small change. They compared data. They adjusted instruments. And again, the result was the same. Nothing. The stars refused to move. But it was not a conscious refusal. It was a lesson in scale. The displacement they expected to find was so tiny that it was buried under other, much larger effects. The atmosphere distorted the light. Instruments expanded with temperature. Mounts vibrated. The human eye introduced imperceptible errors. Even the star's own movement in space added noise to the measurement. Detecting parallax was like trying to hear a whisper in the middle of a storm. During this process, understandable errors were made. Some astronomers announced that they had detected parallax where there was none. Their measurements seemed consistent, but over time they were shown to be illusions caused by instrumental defects or forced interpretations. Each false positive was a disappointment, but also a lesson. Nature was imposing a standard of rigor never before demanded. The truly revolutionary thing about parallax was not the method itself, but what it demanded of the observer: extreme humility. It wasn't enough to see. One had to distrust what was seen. It wasn't enough to measure. One had to measure knowing that almost any result could be an error. It wasn't enough to be right. It had to be proven beyond any reasonable doubt. Over time, instruments improved. Telescopes became more stable. Angular scales were refined. Comparison methods became more rigorous. But still, parallax remained minuscule, so small that it could only be expressed in tiny fractions of a degree. Angles so small they had no equivalent in everyday experience. Here appears one of the most difficult aspects to communicate. Stellar parallax is not small because the method is weak, but because the universe is immense. The repeated failure did not indicate human error, but an uncomfortable truth. The stars were so far away that even the full diameter of the Earth's orbit barely offered a useful perspective. When parallax was finally measured reliably, the result was not spectacular in visual terms. No star jumped clearly in the sky. What was detected was a microscopic displacement, barely distinguishable from instrumental errors. But that small number, that tiny angle, contained colossal information. Translated into distance, that displacement revealed that the observed star was at an unimaginable distance. Not just far, but so far that any terrestrial comparison was useless. The space between the sun and that star could not be meaningfully described in kilometers. It was necessary to invent a new unit, the light year. And even so, that unit remained abstract. Parallax, then, did not just measure distances. It changed the language. It changed the way we talk about space. It forced us to accept that the universe does not fit into our usual words. Hirschfeld emphasizes that this achievement was not the triumph of an individual, but of a scientific culture that learned to be patient. For centuries, humanity was prepared for this measurement without knowing it. It built instruments, refined methods, learned to doubt. When parallax was finally measured, it was not a stroke of luck, but the inevitable result of long collective discipline. The most fascinating thing is that the method remained conceptually simple. There were no complex equations hidden behind it, only basic geometry and rigorous observation. Two viewpoints: a distant object, a small shift. The difficulty was not in the reasoning, but in the scale. This contrast is profoundly human. A simple idea applied to a disproportionate reality. Parallax also revealed something more unsettling. It showed that the sky is not a surface, but a deep volume. That the stars are not hung in a vault, but scattered in all directions. Some relatively close, others much, much farther away, and many so far that their parallax is undetectable even today. Suddenly, the constellations conceptually crumbled. The figures that seemed so clear turned out to be casual alignments. Stars that seemed like neighbors were separated by enormous abysses. The sky lost its ordered appearance and acquired an unsettling depth. But this discovery did not destroy the beauty of the sky. It transformed it. It made it more honest, more complex, more true. Starting with parallax, the universe ceased to be distant decoration and became a measurable, though almost incomprehensible, space, humanity took a decisive step. It stopped assuming and started measuring, even if the result was uncomfortable. And yet, parallax only reached the closest stars. For the rest, the method was not enough. The displacement was too small. The universe remained, in large part, unreachable. But it no longer mattered. We had proven that the method worked. That stellar distance was not an eternal mystery, but a technical challenge. This achievement changed the psychology of astronomy. If one star could be measured, others could too, with better instruments. The problem ceased to be, is it possible? And became, when will we achieve it? That transition is one of the great milestones in scientific history. Parallax did not just measure distances, it taught a profound lesson about human limitations. It showed us that our direct perception is a poor guide for understanding the cosmos. That reality can be radically different from what it seems. That the universe does not adapt to our intuition, and that comprehending it demands patience, rigor, and a constant willingness to accept the unexpected. Today, when we speak casually of stars tens or hundreds of light years away, we forget how violent this conceptual shift was. We forget that for centuries no one could imagine such vast distances without feeling that something was breaking. Parallax was the first serious blow to that comfort. It was the moment when the sky ceased to be close forever. If you wish, I will continue with the next development, where the universe stretches irreversibly, when these first measurements force a redefinition of our real position in the cosmos. There was a silent, almost anticlimactic moment when the universe changed forever in the human mind. It did not happen with an explosion, nor with a dramatic announcement, nor with a sudden revelation visible to the naked eye. It happened in tables of numbers, in notebooks full of annotations, in tiny angles written with endless decimals. But the effect was devastating. For the first time, we not only suspected that the stars were far away, we knew how far away they were, and that knowledge stretched the universe in an irreversible way. Up to that point, even those who intellectually accepted the immense stellar distance still imagined it vaguely. Very far away was a comfortable idea because it did not force them to confront concrete figures. But when parallax began to produce real numbers, the void ceased to be an abstraction. It became quantifiable, and in doing so, it became unsettling. Alan Hirschfeld describes how the first astronomers who managed to measure stellar distances did not react with immediate euphoria. There was, rather, a pause, a kind of intellectual silence. Because those numbers did not fit well into any existing mental framework. They were not just big, they were disproportionate to everything known. Christophe Galfard helps us understand why this impact was so profound. Our brain does not process exponential scales well. We are comfortable with a little more, twice, somewhat bigger. But when numbers skyrocket by enormous factors, intuition is left behind. To understand that a star was several light years away was not just accepting a number, it was accepting that the space between things is the true protagonist of the universe. Suddenly, the solar system ceased to be a grand stage and became a tiny detail, an isolated neighborhood. The sun, which for centuries had been considered a central actor, became one among many, separated from its neighbors by distances so great that the word neighbor began to lose meaning. This was one of the first major psychological shocks, the loss of the center. Not only did the Earth cease to be the center of the universe, as had already happened, but even the sun lost any special privilege. It was an ordinary star, located in an ordinary region, surrounded by an extraordinary void. Galfard insists that this change was not just scientific, but existential. Until then, even in a heliocentric universe, space seemed relatively compact. The stars were far away, yes, but not absurdly far away. With the first real measurements, that illusion broke. The cosmos became disproportionate. The human reaction to this conceptual expansion was ambiguous. On the one hand, there was fascination. The idea of an immense universe aroused awe and curiosity. On the other, there was discomfort. Such a vast universe seemed unnecessary, excessive, almost indifferent to human existence. Why so much empty space? Why separate the stars so radically? These questions were not scientific in the strict sense, but they were inevitable. Science had taken a leap, and human psychology was running behind, trying to catch up. Hirschfeld shows that many astronomers had difficulty communicating these distances, even to their colleagues, not because the data was incorrect, but because the conceptual impact was difficult to convey. Saying that a star was several light years away did not automatically produce comprehension. It produced, rather, silent disbelief. Something interesting happened here. The scientific community began to develop metaphors, comparisons, reduced scales, imaginary models, not because they were exact, but because they were necessary. Without them, the knowledge remained trapped in numbers without emotional meaning. Galfard uses a powerful image. If the solar system were the size of a coin, the nearest star would be kilometers away. That comparison is not meant to be accurate to the millimeter. It is intended to provoke a sensation. It is intended to make one feel the brutal stretching of space. And that stretching had profound consequences. It changed the way we understood the night sky. It was no longer a nearby ceiling full of lights. It was a partial view of a gigantic volume, where each luminous point was separated from the others by distances almost impossible to imagine. Psychologically, this generated a new form of humility. Not moral humility, but spatial humility. We understood that our everyday experience occupies an insignificant fraction of nature's real range, that we live in a bubble of comfortable scales, and that beyond it, everything becomes strange. It also changed the perception of time. If light took years to travel from one star to another, then looking at the sky was, inevitably, looking at the past. This idea, which today seems almost poetic, was initially disturbing. The now ceased to be universal. The present became fragmented. Galfard explains that this discovery forced a rethinking of the very notion of reality. What does it mean for something to exist now if its light has not yet reached us? What does it mean to observe an object that is no longer as we see it? Stellar distance introduced a definitive separation between experience and reality. The universe, once stretched, could no longer be compressed back into the human mind. There was no going back. Although the stars still looked the same to the naked eye, knowledge had forever changed the interpretation. The sky became deep, even when it looked flat. This was also the moment when the void acquired a new scientific dignity. It was no longer simply the absence of things, but an active structure of the cosmos. The space between the stars ceased to be a passive background and became a fundamental element that defined the shape, rhythm, and history of the universe. Hirschfeld points out that, ironically, the more we learned about the stars, the more aware we were of how little they interacted with each other. Each followed its path, isolated, separated by distances that made any encounter extremely rare. The universe was not a tight network, but a scattered collection. This dispersion had a subtle but profound emotional effect. The idea of cosmic solitude began to take shape, not as a philosophical conclusion, but as a geometric consequence. The stars were so far from each other that contact seemed improbable. The vastness of space acted as a natural separator. However, this very stretching also opened new possibilities. If the universe was so big, then there was room for the unexpected, for the diverse, for stories that did not revolve around us. The cosmos ceased to be a designed stage and became an expanding process. This first confrontation with the real distances was not the end of astonishment, but the beginning of a new way of thinking. Accepting that the stars were truly that far away was accepting that reality could surpass any human expectation. When the first stellar distances began to be accepted as real, something curious occurred in the collective mind. The universe has ceased to be merely bigger and became strangely different. It was not a gradual enlargement of the known map, but a rupture, as if someone had suddenly stretched the fabric of reality, separating points that previously seemed close until they became remote islands. Christophe Galfard describes this moment as a kind of forced mental readjustment. Science had advanced faster than intuition, and now intuition had to catch up. For centuries, the sky had been a space that inspired orientation, order, and a certain familiarity. Stars marked seasons, guided journeys, sustained myths. But when we understood how far away they truly were, that familiarity became fragile. The sky was still beautiful, but it was no longer welcoming in the same sense. One of the deepest psychological changes was the loss of the illusion of accessibility. Before, even without technology, the sky seemed close on a symbolic plane. Stars could be gods, destinations, omens. Now they became physical objects, separated by distances so enormous that any idea of direct contact became almost absurd, not due to theoretical impossibility, but due to pure scale. Hirschfeld shows that this discovery introduced a new form of uncomfortable realism. The universe was not organized around human experience, not even indirectly. The distances were so great that they rendered any everyday reference irrelevant. Humanity ceased to be a central point surrounded by nearby lights and became a tiny point floating in a vast network of separations. This change was neither immediate nor uniform. For a time, two mental universes coexisted: the emotional sky, flat and close, and the scientific sky, deep and stretched. People continued to look at the stars as always, but those who knew the numbers could no longer see them the same way. Each luminous point now carried a concrete distance, with a number that radically separated it from the others. Galfard insists that this knowledge does not eliminate the poetry of the sky, but transforms it. Knowing that the light from a star has traveled for years to reach us does not reduce its beauty. It intensifies it, but it also introduces a subtle melancholy. Looking at the sky becomes an act of contemplation of the past. Nothing of what we see is happening now in an absolute sense. This temporal mismatch had a profound psychological effect. The idea of simultaneity fragmented. The universe ceased to have a single present. Each star lives in its own time, separated from ours by distance. Reality became asynchronous, and that is difficult to accept for a mind accustomed to immediacy. Another important effect was the revaluation of the void. Before, the space between the stars was little more than a dark background. Now it became the silent protagonist. Distances were not a secondary detail. They were the dominant feature of the cosmos. The void ceased to be absence and became structure. Hirschfeld points out that this recognition had consequences even in the way science was conducted. Measuring something so distant forced extreme precision, rigorous discipline, and the acceptance of tiny margins of error. Astronomy became a science of patience and humility. It was no longer about observing obvious phenomena, but about detecting almost imperceptible signals buried in the noise. Psychologically, this reinforced a new relationship with knowledge. Understanding the universe ceased to be a matter of intuition and became an exercise of trust in indirect methods. We no longer saw the distances, we inferred them. We no longer felt them, we calculated them. This demanded a rational faith in instruments, models, and processes that escaped direct experience, giving way to a quieter, more spacious image. Galfard suggests that this immensity does not imply hostility, but indifference. The universe does not actively exclude us. It simply does not consider us at all. The distances are not there to isolate us, but because that is how nature works. Accepting this is an act of intellectual maturity. Paradoxically, this stretching of the universe also expanded the sense of belonging. If the cosmos was so vast, then the Earth, however small, acquired a singular value, not for being central, but for being rare, a point where matter had learned to wonder about itself in the midst of a silent immensity. This was another, unexpected psychological effect. Smallness ceased to be humiliating and began to be significant. We were not important because of our position, but because of our capacity to understand. The universe could be immense and empty, but we were capable of measuring it, even with effort. The first real distances also changed the way we imagined the future. Interstellar travel ceased to be a romantic adventure and became an almost philosophical challenge. It was not just about technology, but about time, duration, and continuity. What does it mean to travel when the journey lasts longer than a lifetime? What does it mean to arrive when the starting point has already changed? These questions had no immediate answers, but they profoundly altered the collective imagination. Science fiction, philosophy, and cosmology began to dialogue in new ways. Space was no longer a stage for fast action, but an environment of extreme slowness. Hirschfeld shows that this change was not a loss, but an expansion of the human horizon. The stretched universe forced us to think on larger scales, in longer times, in perspectives less centered on the immediate present. It taught us to think slowly. In the end, understanding how far away the stars truly were did not just stretch the universe, it stretched the human mind. It forced us to accept that reality could be much grander than any story we told ourselves about it. And in doing so, it gave us a new form of wonder. Not the wonder of the near and familiar, but that of the immense and silent. The sky did not change. We changed. When we think about the universe, we almost always think about objects. Stars, planets, galaxies, nebulae, lights, shapes, colors. It is natural. The visible attracts our attention. Our brain is trained to focus on what stands out against the background. But in the cosmos, that habit deceives us, because the truly dominant element is not what shines, but what we don't see. The space between the stars is not a simple, empty stage. It is the main element. It is the great invisible protagonist. Christophe Galfard insists that if we could mentally erase all the stars in the universe and keep only the space that separates them, we would not be losing essential information. On the contrary, we would be observing the real structure of the cosmos. Stars occupy a ridiculously small fraction of the total volume. They are luminous exceptions in an immense ocean of void. And it is that ocean that defines how everything works. This void is not a trivial nothing. It is not an unimportant whole. It is the medium through which light travels, the space where time stretches, the stage where forces act over enormous distances. Without that void, stars could not exist as separate entities. They would collapse, collide, and mix. The universe would be unrecognizable. But our intuition rejects this idea. We tend to think that what is important is the solid, the visible, the tangible. In our everyday experience, the space between objects is usually irrelevant. A table matters more than the air around it. A person matters more than the space they occupy when moving. In the cosmos, the opposite is true. Space is essential. Matter is secondary. Galfard proposes an unsettling thought experiment. Imagine that all the stars in the galaxy suddenly disappear, but the space remains. The gravitational structure would still exist. The distances would continue to define relationships. Time would continue to flow. The universe would not collapse in the immediate sense. However, if space disappeared and the stars remained, there would be no universe possible. Everything would instantly collapse. This contrast reveals an uncomfortable truth. We are obsessed with the secondary actors and forget the main protagonist. The void between stars is so dominant that even the stars themselves spend most of their existence isolated, without interacting directly with any other. They do not communicate. They do not exchange matter. They do not immediately feel the presence of their neighbors. Distance acts as an absolute damper. The universe is not a conversation. It is a silent coexistence. Here appears one of the most common misunderstandings, thinking that the void is simply the absence of things. In reality, the void is an active condition. It allows light to travel unobstructed for years, centuries, and millions of years. It allows information to propagate slowly. It allows events to be separated in time as much as in space. The light from a star crosses space not because it is empty, but precisely because it is empty. If space were filled with matter, light would scatter, be absorbed, or be lost. The sky would be opaque. We would not see distant stars. The void is what makes the vision of the cosmos possible. Galfard stresses that this void is not uniform in the everyday sense. It is not a passive nothing. It has properties. It can stretch. It can curve. It can influence the movement of matter and light. The space between stars is not a rigid container, but something dynamic, flexible, sensitive to what happens within it. But even setting aside these deeper properties, the simple fact of its extent already makes it the dominant element. The average distance between stars is so great that if we traveled for an entire lifetime at an enormous speed, we would spend most of the time without seeing anything new. Only darkness, only silence. This silence has a powerful psychological effect. The universe does not shout at us. It does not impose itself. It does not seek our attention. It is vast and quiet, and that is unsettling for a species accustomed to interpreting meaning in every signal. The void offers no clear messages. It tells no stories. It is just there. For a long time, this void was ignored even in science. Early theories focused on the objects, stars, planets, orbits. Space was treated as a simple, neutral background. But little by little, it became evident that this approach was insufficient. The behavior of the universe could not be understood without paying attention to space itself. Galfard explains that even the stability of the stars depends on the immensity of the void surrounding them. The fact that they are so separated avoids constant destructive interactions. Distance is a form of protection. Isolation is a condition for survival on a cosmic scale. Here arises a surprising idea. The void is not hostile to life. It is what makes it possible. A compact universe full of matter would be violent, chaotic, and unstable. Ours, on the other hand, is vast, spaced out, and slow. The void acts as a regulator, as a natural break. The space between the stars also redefines our notion of travel. It is not just about going from one point to another, but about crossing enormous regions where nothing remarkable happens. There are no intermediate landmarks. There are no visual references. Stellar travel is not an adventure full of events, but a journey of extreme patience. This clashes with our narrative imagination, which tends to fill in the blanks. But the universe does not fill its blanks. It leaves them empty. Galfard invites us to accept this idea without drama. The void is not a deficiency, it is a characteristic. It is not there because stars are missing, but because nature works that way. Matter groups in points, and the space between them extends unhurriedly. Understanding this changes the way we look at the sky. Each star ceases to be just a bright object and becomes a distance marker, a point that indicates how great the void surrounding it is. The true scale of the cosmos is not measured by counting stars, but by measuring what separates them. This approach has a profound consequence. It forces us to shift our attention from the spectacular to the invisible, to value what is not seen, to understand that absence can be more significant than presence. In this sense, the void between stars is neither a design flaw nor a waste of space. It is the very foundation of the universe as we know it. Without it, there would be no stability, no traveling light, no cosmic history. And perhaps the most disconcerting thing is that we live immersed in that void without noticing it. Our existence occurs on a small island of matter, but that island floats in a silent immensity that defines every aspect of reality. Accepting that the void dominates the universe is not only an intellectual adjustment, it is a profound change in the way we interpret reality. When we stop focusing solely on the stars and start thinking about the space that separates them, the cosmos ceases to seem like a collection of objects and begins to feel like a process, something that happens slowly, almost silently, on scales not meant to be experienced by a human mind. Galfard insists that the void is not an inert stage where things just happen, but the element that dictates the rhythm of the universe. The enormous separation between stars imposes a fundamental slowness. Nothing happens fast on a cosmic scale. Important changes need millions of years. Even the most violent events are diluted in the immensity of space, losing urgency, losing immediate impact. This forced slowness transforms our relationship with time. In a compact universe, events would be chained quickly, almost chaotically. In contrast, the void introduces gigantic pauses. Between one event and another, there are silences so long that they defy any human notion of waiting. The cosmos is not in a hurry, and that lack of hurry is a direct consequence of the space that separates its components. The void also defines what can influence what. A star can burn with unimaginable energy, but that energy disperses in all directions, diluting as it crosses space. Over great distances, even the most intense phenomena become barely perceptible. The void acts as a universal damper. Nothing immediately dominates everything else. This has an important implication. The universe is inherently local. Each region lives, to a large extent, its own history. Stars evolve without knowing what is happening in distant systems. Galaxies develop in isolation for millions of years. The void separates cosmic narratives, allowing multiple stories to coexist without interfering with each other. From this point of view, the universe is not a single, continuous narrative, but an immense collection of parallel processes connected only very tenuously by light and gravity. The space between stars not only separates bodies, it separates histories. Galfard stresses that even information is limited by this void. Nothing can travel faster than light, and light needs time to cross enormous distances. This means that knowledge of the universe always arrives late. We never see events at the moment they occur. We always observe them later, sometimes much later. The void turns the cosmos into a permanent historical archive. This idea profoundly alters the notion of present. In everyday life, we take it for granted that the present is shared, that what happens here happens at the same time in other places. On a stellar scale, that assumption breaks completely. Each point of the universe lives in its own now, separated from ours by the space that light must cross. The void, then, does not only separate physically, it separates temporally. Space and time cease to be independent concepts and become aspects of the same structure. Distance creates past. The further we look, the further back in time we see. And because the stars are so separated, the entire sky is a superposition of different pasts. This discovery does not make the universe colder or more distant in an emotional sense. It makes it more complex. Every star we see is an ancient message. Every point of light is a story that began before we existed. The void is the silent messenger that transports those stories without interpreting them, without modifying them. There is another, less obvious but equally important aspect. The void conditions the very possibility of encounter. In such a spaced-out universe, encounters between systems are rare. Collisions, shocks, and mergers exist, but they are exceptional events on enormous timescales. The norm is separation. Distance is the natural state. This explains why the universe can be stable for such long periods. The void reduces the probability of frequent destructive interactions. Stars can live for billions of years without nearby interference. Galaxies can maintain their structures for eons. Space acts as a mechanism of natural isolation. From a human perspective, this isolation can be interpreted as solitude. But Galfard invites us to see it another way, as a condition of possibility. Without that extreme separation, complexity would not have time to develop. Everything would be too close, too influenced by everything else. The void also redefines the idea of a border. There are no clear limits between regions of space. There are no walls, no physical divisions. There are only increasing distances. Moving from one star to another does not involve crossing a visible border, but traversing a gradient of nothingness. This makes the universe continuous, but not homogeneous in experience. For a human mind, this type of continuity is difficult to assimilate. We prefer clear boundaries, visible transitions. The void offers neither. It is uniform in appearance, but immense in extent. It gives no signs of progress. It does not mark stages. It simply extends. Galfard suggests that this characteristic of the cosmos is a lesson in cognitive humility. It reminds us that not everything in nature is designed to be perceived or understood intuitively. Some of the most important things are not seen, not felt, and not experienced directly. They are inferred. They are accepted. They are respected. When we understand that the void is more important than the stars, our way of asking questions changes. We stop asking only, what is there, and start asking, what separates? We stop focusing solely on objects and begin to think about the spatial relationships that define them. This perspective also changes our emotional relationship with the cosmos. The universe ceases to be a place crowded with things and becomes an open, silent, almost meditative space. Immensity is no longer perceived as a threat, but as context. A context that does not revolve around us, but that allows our existence. In this sense, the void is not a negation of meaning, but an invitation to redefine it. The meaning is not in the quantity of things, but in the rarity that something exists in the midst of so much space. Each star, each planet, each form of life becomes more valuable precisely because it emerges from an environment dominated by nothingness. Accepting the starring role of the void is accepting that the universe is not designed for constant spectacle. It is a patient, spaced out, silent system. And in that silence, paradoxically, there is a profound form of coherence. When we look up at the sky and see stars scattered against a dark background, we are not seeing a lighting failure. We are seeing the true nature of the cosmos, a place where space rules, where separation defines the structure, and where the invisible sustains all that is visible. There is a reason why, when we think about traveling to the stars, we almost always do it with imagination and not with real maps. The mind can move without friction, without fuel, without wear and tear. It can jump from one point in the universe to another in an instant. The body, on the other hand, is trapped in time. And time, when mixed with stellar distance, becomes the true obstacle. Christophe Galfard explains that the problem with stellar travel is not just technological. It is not a matter of more powerful engines or better designed ships. It is a problem of waiting, of duration, of accepting that the universe moves at a rhythm that does not match that of a human life. When we imagine traveling to a nearby star, we usually do so with a deceptive lightness. We say, the closest, as if that implies something accessible. But even the nearest star is separated from us by a distance that light takes more than 4 years to cross. And light never stops. It travels at the absolute speed limit allowed by the universe. Here, a first mental shock appears. Nothing can go faster than light. It is not a technological limitation, but a profound rule of reality. The universe imposes a maximum limit on the speed at which anything can travel, including information. This means that even in the most optimistic scenario imaginable, no stellar journey can be fast. Galfard insists that light is not slow. On the contrary, it is so fast that it completely escapes our everyday experience. It circles the Earth several times in a second. It crosses planetary distances in minutes. And yet, when it comes to stars, its speed proves insufficient to make the journey seem brief. If a ship could travel at the speed of light, something that, according to known laws, is not possible for an object with mass, it would take years to reach the nearest star. At more realistic speeds, even the most extreme we can imagine with known physics, the journey would extend for decades, centuries, or more. This is where the mind begins to intervene as a defense mechanism. In order not to confront this waiting, we tend to compress time in our imagination. We think of the journey as a continuous, fluid, almost immediate trajectory. But the reality is different. Stellar travel is above all an experience of prolonged waiting. Galfard describes the space between stars as a temporal desert. Not only is there little matter, there is little change. For years of travel, the landscape does not vary. There are no references. There are no intermediate landmarks. only a near-perfect darkness dotted with distant lights that barely change position. This type of journey is unlike anything we have experienced as a species. Even the longest journeys in our history have always had waypoints: coasts, islands, cities, stations. Interstellar space offers none of that. It is a continuous expanse of void where time becomes the only constant companion. Here, a key idea from Galfard appears. The true cost of stellar travel is not energy, but patience. A light-year journey is paid for not only with fuel, but with human lives, with generations, with cultural continuity. Distance converts time into currency. If a ship were to leave today for a nearby star at a significant fraction of the speed of light, those who arrive would not be the ones who departed. The journey would be marked by aging, by change, by inevitable transformation. The destination would be far away not only in space, but also in the future. This idea has a profound psychological effect. It forces us to think of travel not as displacement, but as temporal transition. Traveling to the stars is, in a sense, traveling toward a world that no longer shares our present. Home is left behind not only in distance, but in era. Light gives us an important clue about this. When we look at a star, we see what it was like years ago. When we travel toward it, we move toward its present, but slowly. The journey is a chase for the now that is never fully reached until the end. Galfard uses a powerful image. Moving through space is like walking inside time. Every kilometer traveled is also a step toward the future. In the universe, space and time are inseparably intertwined. Distance is not just a spatial measure, it is a duration. This entanglement makes stellar travel radically different from any terrestrial displacement. On Earth, the time of the journey is usually a secondary inconvenience. In space, time is the journey. One cannot separate the two. That is why the human mind prefers to imagine stellar travel as an instantaneous leap. Teleportation, shortcuts, portals. Not because they are realistic, but because they alleviate the psychological burden of waiting. But known physics does not offer those conveniences. The universe is honest, but demanding. Galfard emphasizes that even if we could travel at speeds close to light, new unsettling effects would arise. Time would not pass the same way for those traveling and for those staying behind. Relativity comes into play, distorting the temporal experience. For travelers, time might pass more slowly. For those remaining on Earth, the journey would seem eternal. This mismatch introduces another layer of strangeness. The return, if it were to happen, would be a return to a changed, aged, different world. Stellar travel is not an excursion. It is a temporal rupture. The waiting, then, is not just boredom or impatience. It is transformation. During such a long journey, everything changes. The traveler changes. The starting point changes. Even the destination changes, because stars evolve, move, and age. Galfard insists that this reality does not make stellar travel impossible, but it redefines it completely. It is not about going and coming back. It is about going, about accepting that the journey and the destination cannot be separated from the time that connects them. When the mind crosses the universe in seconds, it is not denying reality. It is reminding us of something essential. Imagination is the only truly fast means of transport we possess. Through it, we can explore without waiting, without aging, without losing entire generations in the journey. But this advantage comes at a price. Imagination does not experience the waiting. And without the waiting, the true scale of the cosmos is not fully comprehended. Understanding how long any stellar journey would really take is not an exercise in pessimism, but in honesty. It forces us to recognize that we live in a universe where distance and time are inseparable, and where patience is not an optional virtue, but a fundamental condition. When we accept that stellar travel is, above all, a matter of time, a new way of understanding the universe appears, not as a space that is crossed, but as a duration that is inhabited. Christophe Galfard insists that light is the key to understanding this idea, not only because it is the fastest thing that exists, but because it acts as the natural clock of the cosmos. Everything we know about the universe is marked by the time light has taken to reach us. Every time we look up at the sky, we are participating in a journey without moving. The light that enters our eyes has traveled enormous distances, crossing the void for years, decades, centuries, or even longer. That light brings not only images, it brings time. It brings aged information. It brings stories that began before we were here. Galfard explains that observing the universe is a way of traveling without displacing oneself. We do not go toward the stars. The stars come toward us in the form of light. But that journey also has its price: the waiting. Information is never immediate. It always arrives late. The universe does not offer real-time updates. This radically transforms our relationship with knowledge. In everyday life, we expect quick answers. We want to know what is happening now. In the cosmos, that expectation is meaningless. The now is local, limited, fragmented. What we see in the sky is a superposition of different times, each separated by the distance that light has had to travel. The waiting, then, is not an accidental obstacle. It is a fundamental characteristic of the universe. Everything is separated by time as much as by space. And that separation imposes a form of cosmic patience that we cannot avoid. Galfard uses a simple but powerful image. Looking at a star is like reading a letter written years ago. The message is authentic, but it is not contemporary. We cannot respond expecting an immediate reaction. The universe does not converse, it communicates with delay. This delay has profound implications for any idea of travel. Even if a ship could approach the speed of light, it could never eliminate the waiting completely. The journey would still last years, and during that time, everything else would continue to advance. The journey does not freeze the universe. It only freezes the traveler relative to their starting point. Here arises an unsettling paradox. The faster something travels, the more its relationship with time is distorted. For the traveler, time might pass differently, but for the rest of the universe, the waiting remains the same. The journey is not truly shortened, it is only experienced differently. Galfard points out that this temporal mismatch is not a technical detail, but a direct consequence of the structure of the universe. Space and time are intertwined. One cannot traverse one without altering the experience of the other. Traveling far is traveling in time, whether we want to or not. The waiting also redefines the concept of hope. In human culture, waiting usually implies a near reward: to arrive, to see, to touch. In the stellar context, the reward is so far away that it ceases to be personal. The journey is justified not by what the traveler will see, but by what it will make possible for those who come after. This introduces an entirely different ethical scale. Stellar travel cannot be an individual act. It is necessarily collective, intergenerational. It implies continuity, memory, transmission. It implies accepting that the result will not be lived by those who initiated it. Galfard suggests that this type of project challenges our deepest psychology. We are accustomed to seeing the fruits of our efforts within our own lifetime. The universe, on the other hand, invites us to think on scales where effort and result are separated by generations. Light, once again, offers us a lesson. Light leaves without knowing who will receive it. It travels for years without guarantee of reaching an observer. And yet, it keeps traveling. It is not in a hurry. It does not tire. It does not expect recognition. It simply moves forward. Understanding this changes the way we think about movement. Traveling is no longer just displacement, but participating in a long, silent, almost meditative process. The universe does not reward speed for its own sake. It rewards constancy. Even without ships, we are already immersed in this process. The Earth moves, the sun shifts, the galaxy rotates. Everything travels, slowly, without urgency. We live in a universe of constant motion, but so slow on our scale that it seems static. Galfard highlights that this slowness is not a defect, but an essential characteristic. It allows for stability. It allows for complexity. It allows for the existence of durable structures. A fast universe would be chaotic. Ours is patient. When we accept that any stellar journey is dominated by waiting, we stop seeing it as a race and start seeing it as an inner journey. The challenge is not to arrive quickly, but to accept the rhythm of the cosmos, to adjust our expectations, to recognize our limits. The human mind can traverse the universe in seconds, but the body belongs to time. This difference is not a frustration. It is an invitation to understand. Imagination shows us the possible. Physics reminds us of the real. Between the two, a more honest relationship with the cosmos is built. Traveling at the speed of mind allows us to explore without waiting. But understanding how long any stellar journey would really take brings us back to silence, to patience, to the acceptance that the universe is not made to be traversed in a hurry. And perhaps therein lies one of its deepest lessons. Not everything is destined to be achieved quickly. Some realities exist to be contemplated, understood, and respected, not conquered. In that sense, every time we look at a star, we are already traveling, not toward it, but toward a broader understanding of our place in a universe where time and distance always walk hand in hand. There is something profoundly unsettling in the idea that seeing far is, in reality, seeing back. Not back in space, but back in time. This idea does not impose itself suddenly. It filters slowly, almost without our realizing it, until one day it ceases to be a scientific curiosity and becomes a fissure in our everyday way of understanding the present. Christophe Galfard explains that our intuition of the now is built from immediate experiences. We speak, we listen, we respond. We look at something and assume that it exists exactly as we see it at that instant. This assumption works well in daily life because the distances are small and light. It takes so little time to travel them that the delay is imperceptible. The world seems synchronized. The present seems shared. But the universe does not work that way. As soon as we look up at the sky, this synchronicity breaks. Light no longer takes fractions of a second, but minutes, hours, years. Each star introduces a different delay. Every luminous point belongs to a different time. The night sky is not an image of the present, but a superposition of pasts. Kees Boeke helps us understand this with his focus on scales. When we take small leaps in distance, the temporal delay remains manageable. We see the moon as it was just over a second ago, the sun as it was a few minutes ago. None of this seriously alters our intuition. But when we continue to move away, when we move to nearby stars and then to distant ones, the delay grows until it becomes impossible to ignore. Here, the rupture occurs. A universal now does not exist. Each distant object lives in its own present, inaccessible to us. The only thing we receive is its past, transported by light through the void. The greater the distance, the deeper the temporal leap. Looking far is not expanding the visual field. It is stepping back in history. Galfard insists that this is not a poetic metaphor, but a physical reality. Light is the messenger of the universe and travels at a finite speed. No matter how powerful the telescope is, it cannot bring information faster. It cannot show us the present of a distant star. It can only show us what it was. This fact has profound consequences for our relationship with reality. We are accustomed to thinking that observation is a passive, almost instantaneous act. But in the cosmos, observing is an archaeological act. It is unearthing ancient signals. It is rebuilding histories from fragments that arrive late. Bokeh underscores that, as we expand the scale, the sky becomes a museum of time. Each region of space corresponds to a different era. The universe is not displayed as a frozen scene, but as a collection of out-of-sync moments. This generates a strange feeling. The present becomes local. We can only be sure of the now in our immediate vicinity. Beyond that, everything is informed conjecture. The distant universe is always a delayed version of itself. Our intuition resists accepting this because it contradicts one of the most basic ideas of our experience: that time flows uniformly for everyone. In everyday life, that assumption is functional, but in the cosmos, it is false. Time is not globally shared. It is fragmented by distance. Galfard explains that this discovery forced a rethinking of what it truly means to see. Seeing is not directly accessing reality. It is receiving delayed information. The universe is not presented to us in real time. It is presented to us as an echo. This echo is not a flaw in the cosmos. It is an inevitable consequence of its size. If the universe were small, everything would be synchronized. But being immense, the synchronicity breaks down. Distance turns time into an observable variable. Bokeh shows that this effect becomes increasingly evident as we advance in scale. In the stellar neighborhood, the delay is already years. In more distant regions, it is thousands, millions, even billions of years. The deep sky is a window open to eras when the Earth did not even exist. Here, a fascinating paradox appears. The further we look, the younger the universe we see. The most distant regions show us a cosmos in early stages of its history. Space functions as a natural time machine, not because it travels backward, but because it preserves the past in the form of light in transit. This idea breaks another fundamental intuition, that the past is closed and the present is the only thing accessible. In the universe, the past continues to travel. It continues to propagate. It is not archived. It is in motion. Galfard insists that this reality does not make the universe confusing, but coherent in another way. The cosmos is not a snapshot. It is an ongoing narrative, where every photon is a sentence that takes time to reach the reader. This approach changes our emotional relationship with the sky. Stars cease to be mere fixed points and become messengers. Each one brings ancient news, information that has survived enormous distances. Looking at the sky becomes an act of patient reading. Bokeh emphasizes that this delay cannot be eliminated with technology. No matter how advanced a telescope is, it cannot violate the speed of light. The limit is not technical, it is structural. The universe is built in such a way that the now cannot be global. This has a profound psychological consequence. It forces us to abandon the idea of temporal control. We cannot know what is happening now in distant places. We can only infer it from their past. Knowledge always arrives late. Far from being a disadvantage, Galfard suggests that this characteristic makes the universe more interesting. It forces us to think in terms of processes, not states. We do not see objects as they are, but as they were. Reality becomes dynamic even when it appears static. This rupture of the now also affects our notion of simultaneity. Two events that appear to happen at the same time from our perspective can be separated by millions of years in absolute terms. The universe does not share our clock. Accepting this is difficult because it deprives us of a comfortable reference, but it also offers us a deeper understanding. It shows us that time is not a uniform background, but something that emerges from the structure of space. When we look far, we do not just expand our vision, we expand our temporal consciousness. We learn that the present is a local experience, not a universal property. In the next part, we will delve even deeper into this idea. How this rupture of the now transforms our way of thinking about reality, causality, and our own position within a universe where everything we see is, inevitably, a memory in motion. When we accept that looking far is looking back, something deeper than a simple scientific correction occurs. A silent fracture takes place in our way of understanding reality. We stop living in a universe where everything is happening now and start inhabiting one where the present is a local privilege, limited to our immediate surroundings. Beyond that small circle, everything is memory in transit. Kees Boeke helps visualize this idea with his particular way of scaling the universe. Each leap in distance not only expands space, it also stretches time. At first, the delay is insignificant. Then it becomes perceptible. Later, dominant. Finally, overwhelming. Distance is not limited to separating places. It separates entire eras. This effect has an unexpected consequence. The sky ceases to be a scene and becomes a sequence. We are not observing a frozen instant of the universe, but an extended narrative, where each point belongs to a different chapter. Some stars show us relatively recent events. Others tell us about a past so remote that the Earth did not even exist when that light departed. Christophe Galfard insists that this temporal superposition is not a perceptual error, but an essential property of the cosmos. The universe does not offer a synchronized image because it cannot do so. Its size prevents it. Space acts as a natural separator of times, creating a fragmented reality where the now ceases to have global meaning. This radically alters our relationship with truth. In everyday life, we tend to associate truth with currency. The true thing is what is happening now. But in the cosmos, the true thing is what reached us, even if it happened millions of years ago. Astronomical truth is always retrospective. This idea is uncomfortable because it forces us to live with uncertainty. We do not know what is happening right now in the stars we see. We only know what happened when their light began the journey. The present of those places is, for us, a conjecture. The universe does not allow itself to be spied on in real time. Boeke shows that this limitation is not a defect of our instruments, but an inevitable consequence of scale. Even if we had infinitely better technologies, the delay would still be there. There is no way to skip time when the distance is so vast. The cosmos imposes its own rhythm. This fact also changes the way we understand causality. In our daily experience, causes and effects seem close in time. Something happens, and shortly after, we see its consequences. In the universe, the cause may have occurred millions of years ago, and the effect only manifests now, when the light reaches us. Thus, the sky becomes an archive of ancient causes whose effects we continue to receive. Every observation is a reconstruction. Every image is an interpretation of the past. Astronomy is not just a science of space, it is a science of deferred time. Galfard suggests that this condition transforms the contemplation of the cosmos into a deeply philosophical act. Looking at the sky is no longer seeking immediacy, but accepting the impossibility of being up to date with the universe. Cosmic knowledge always arrives late, and learning to live with that delay is an essential part of understanding reality. This rupture of the now also affects our perception of permanence. Stars seem stable, almost eternal. But that stability is deceptive. What we see is an ancient version, frozen by distance. In reality, many stars change, evolve, and even disappear, while their image is still traveling toward us. Boca emphasizes that this disconnection between what we see and what is introduces a new form of humility. We cannot assume that our visual experience reflects the current state of the universe. Observation ceases to be a faithful mirror and becomes a temporal window. This fact has a subtle but powerful emotional consequence. The sky ceases to be something present and becomes something inherited. Every night we receive a legacy of light, a collection of ancient messages that we continue to interpret. The universe does not speak to us live, it leaves us letters. Galfard uses this idea to show that the cosmos is not indifferent, but neither is it immediate. It is connected to us through time, not the instant. The relationship is not one of simultaneity, but of continuity. Accepting this changes the way we think about our own existence. We live in a tiny present, surrounded by immense pasts. Our life occurs in an interval so brief that it is almost invisible on a cosmic scale. And yet, we are capable of reconstructing stories that stretch over billions of years. This capacity does not eliminate the temporal distance, but it makes it comprehensible. It allows us to navigate a universe where the now is rare and the past is omnipresent. The human mind learns to move in this paradox, living in the present while constantly observing the past. Boca points out that this learning is not intuitive, but acquired. It requires abandoning the idea that time is universal and accepting that it is local, that each region of the universe lives at its own pace, that there is no master clock synchronizing everything. This change of perspective also redefines the notion of closeness. Something may seem close in the sky and yet be separated by millions of years in time. Distance is no longer measured only in space, but in history. Galfard insists that this understanding does not make the universe colder, but deeper. Every point of light becomes a testimony. Every observation is an encounter with a past that has survived the journey. The sky ceases to be a backdrop and becomes a slow conversation between eras. When we accept that a global now does not exist, we stop looking for it. We begin to think in terms of long processes, gradual evolutions, and stories that unfold unhurriedly. The universe does not need synchronicity to be coherent. This rupture also frees us from an unfair expectation, that of understanding everything immediately. The cosmos teaches us that some truths are only revealed with patience, accepting the delay, accepting the temporal fragmentation. Looking far, then, is not just looking back. It is learning to live in a universe where the present is small, the past is vast, and the future is always outside our immediate reach. A universe where reality is not handed over all at once, but in layers of light that arrive when they can, not when we want. And in that constant waiting, paradoxically, we find one of the deepest forms of connection with the cosmos, not as spectators of the now, but as attentive readers of a story that continues to be written, even as we read it. When we pronounce the name Milky Way, almost without realizing it, our mind draws a deceptive image. We imagine a luminous strip crossing the sky, a dense concentration of stars packed closely together, forming a kind of bright river. From Earth, that vision seems reasonable. The Milky Way presents itself as a compact, almost solid cluster, a path of light cutting across the night. But that appearance is a profound illusion. The reality is much more unsettling. Christophe Galfard explains that the Milky Way is not an object filled with stars, but a gigantic volume dominated by the void. The stars that compose it do not form a tight swarm, but are separated by distances so enormous that even within the same galaxy, solitude is the norm. What we see as a luminous strip is simply the effect of looking along the galactic plane, passing through an enormous amount of space where, every now and then, a star appears. The Milky Way is less a crowded city and more an ocean, a dark, silent ocean, where every star is an isolated island, separated from the others by expanses of void that exceed any human scale. When we understand this, the phrase stellar neighborhood begins to sound almost ironic. Our sun, for example, does not live in a particularly crowded environment. It is located in a relatively quiet region of the galaxy, far from the dense and active core. The nearest stars seem, on maps, to form a small group. But that closeness is misleading. Even the so-called neighbor stars are so far apart that no direct exchange occurs between them for millions of years. Galfard insists that the galaxy is not a compact structure, but a vast dispersion. If we could observe the Milky Way from outside, we would not see a solid mass of light, but a huge, faint cloud, where most of the volume would be completely empty. The density of stars is incredibly low, so low that, if we were floating in the space between any two stars, we would see nothing to indicate that we are inside a galaxy. This idea is difficult to accept because it contradicts our visual experience. From Earth, the Milky Way seems intense, luminous, full, but that intensity does not come from the closeness of the stars, but from their accumulated number along an extremely long line of sight. We are looking through an immense galactic depth. The brightness adds up, but the distance does not disappear. Here appears one of the most persistent misunderstandings, thinking that the galaxy is a place where stars are together. In reality, the galaxy is a frame of reference, not a filled space. Stars do not coexist closely, they coexist at a distance. Galfard compares the Milky Way to an infinite library where each book is placed kilometers from the next. From afar, we might think there is a great concentration of knowledge, but upon approaching, we would discover that each volume is completely isolated. The galaxy works similarly. The whole seems coherent, but the local experience is one of extreme solitude. Even in denser regions of the galaxy, such as star clusters, the separation is still enormous. The stars are not close enough for the light from one to constantly illuminate another directly. The space between them dominates the scene. Gravity maintains the general structure, but it does not create closeness in the everyday sense. This ocean of incomprehensible distances has profound consequences. The first is that the galaxy is incredibly stable. Stars rarely collide with each other. Millions of years can pass without close encounters. The void acts as a natural damper, allowing the Milky Way to exist for immense periods without collapsing. The second consequence is psychological. We tend to imagine the galaxy as a shared home, a cosmic community. But the reality is that each star lives its own story, isolated, disconnected from the others in practical terms. The idea of a galactic home is a human construction, not a physical experience. Galfard stresses that even within the same galaxy, communication is slow. Light takes years, decades, or centuries to cross the distances between nearby stars. There are no quick conversations. There is no immediate exchange. Everything happens with delay. The galactic ocean imposes its rhythm. This fact transforms the way we understand potential life in the galaxy. Even if countless civilizations existed, they would be separated by distances so great that contact would be extraordinarily difficult, not due to a lack of technology, but due to the very geometry of space. The galaxy does not favor interaction. It favors distant coexistence. The notion of neighbor stars is therefore revealed to be an extreme simplification. Neighbors in galactic terms does not mean close in human terms. Two stars can belong to the same galactic region and still be separated by distances that no human journey could cover in one lifetime, nor in 100. Galfard insists that this dispersion is not a flaw in the universe, but a fundamental condition. The galaxy is not a swarm because it does not need to be. Its structure emerges precisely from separation. Space allows each star to evolve independently without constant interference. This isolation also explains why the night sky changes so slowly. Stars appear fixed because, in effect, they are on human scales. Their relative movement is so small compared to the distances that it is barely perceptible even over centuries. The galaxy is dynamic, but its dynamism is extremely slow. When we look at the Milky Way, we are seeing a system in unhurried motion. Stars orbit the galactic center, but they do so with periods so long that a human life is not enough to notice significant changes. The galactic ocean moves, but like a deep sea, not like a surface current. This slow pace reinforces the illusion of stability. It makes us think that the galaxy is eternal, immutable. But Galfard reminds us that even this immensity has a history. The Milky Way was born, grew, interacted with other galaxies, and will continue to change for billions of years. What we see now is only a temporal snapshot. The difference is that this snapshot is composed of distances so enormous that change becomes invisible. The galactic ocean transforms, but it does so at a rate that escapes our direct perception. Another important consequence of these distances is the loss of references. Within the Milky Way, there are no privileged points from which to observe the entire ensemble. Each star has its own sky, its own perspective, its own luminous strip. There is no shared visual center. The galactic experience is local. Galfard points out that this reinforces a key idea. The universe is not designed to be observed from a central point. There is no place from which everything makes immediate sense. Each observer reconstructs the cosmos from distant, delayed, fragmented signals. In this context, the Milky Way ceases to be an object and becomes a concept. It is not something we can experience directly, but something we infer from partial observations. We know we are inside it not because we see it whole, but because the data fits. This knowledge is powerful precisely because it is not intuitive. It forces us to accept that we live immersed in a structure that completely surpasses our scale. A structure where stars do not form a close community, but a dispersed collection held together by invisible forces across gigantic distances. Galfard invites us to think of the galaxy not as a cozy home, but as a vast, neutral, silent environment. Not hostile, but not designed for closeness either. A place where separation is the norm and interaction is the exception. This vision may seem cold, but it is also profoundly liberating. It allows us to abandon the need for centrality. It places us as inhabitants of a tiny island within an immense galactic ocean. We are not special because of our position, but because of our capacity to understand it. The Milky Way, viewed this way, ceases to be an accumulation of lights and becomes a lesson in scale. It teaches us that even within the same galaxy, distance reigns. That closeness is relative. That what looks adjacent from afar can be separated by abysses. And perhaps that is one of the hardest truths to accept, that we live in a universe where even our neighbors are incredibly far away, and where the true structure is built, not with matter, but with space. Looking at the Milky Way is no longer seeing a river of stars, but contemplating an ocean of incomprehensible distances, where every point of light marks not only the presence of a star, but the immensity of the void that surrounds it. There is a profound reason why, even after hours of reading, listening, or watching documentaries, cosmic distances still feel unreal. It is not a lack of interest. It is not a lack of intelligence. It is something much more basic. The human brain is not built to understand these scales, not because they are mathematically complex, but because they are outside the range for which our mind evolved. Christophe Galfard explains that our perception of the world was born to solve immediate problems, avoiding danger, finding food, recognizing faces, orienting ourselves in relatively small spaces. Our entire cognitive system is tuned to move easily within meters, kilometers, and, with effort, perhaps continental distances. Beyond that, we begin to lose our footing, not because the numbers are large, but because they lose their emotional anchor. Kees Boeke shows this clearly. The brain understands gradual changes well, but it becomes disoriented by leaps in scale. Going from a room to a city is still comprehensible. Going from a city to the entire planet already begins to feel abstract. Going from the planet to the stars breaks something. There is no prior experience to prepare us for that jump. Our brain does not work with absolute numbers, but with comparisons. It needs references. It needs to know what is bigger or further in relation to something known. The problem is that when we talk about stellar distances, there is no valid everyday reference. Nothing in our life even approaches those magnitudes. The comparison is left without ground. That is why we resort to metaphors, not because they are exact, but because they are necessary. We say a star is light years away. The galaxy is an ocean, and stars are islands. These images do not describe reality accurately, but they allow the brain to hold on to something. They are cognitive crutches. Without them, the information does not integrate. It floats. Galfard insists that this use of metaphors is not a weakness of scientific knowledge, but an intelligent adaptation. Science produces numbers. The mind needs stories. To truly understand, both must meet at some intermediate point. The problem arises when we confuse the metaphor with reality. when we believe we understand a distance because we have a nice image in our head. In reality, we have only domesticated the idea enough not to feel uncomfortable. The true scale remains as strange as before. Buke shows that the human brain functions well on linear scales, but fails on exponential scales. If something is twice as big, we understand it. If it is 10 times bigger, we can still imagine it. But when something is millions or billions of times bigger, intuition collapses. All those numbers start to feel the same. They lose qualitative meaning. This collapse is one of the great obstacles to understanding the universe. Saying one star is 4 light years away and another is 4,000 light years away produces a similar emotional reaction. Both are very far away. The brain does not distinguish well between extreme levels of distance. Everything that exceeds a certain threshold becomes a single mental block, the unattainable. Galfard explains that this happens because our brain did not evolve to handle such large orders of magnitude. It did not need to. To survive, it was enough to distinguish the near from the far on practical scales. The cosmos was not on the evolutionary agenda. This has an important consequence. Understanding cosmic distances is not intuitive, it is learned. It does not arise naturally. It requires mental training, repetition, and constant exposure to ideas that contradict our direct experience. Even so, the comprehension is never complete. A feeling of unreality always remains. Bokeh proposes that we accept this limitation instead of fighting against it. We are not failing by not feeling the scale of the universe. We are acting exactly as a normal human mind. The error would be to demand that the brain function outside its natural range without conceptual aids. This is where chain scales, progressive jumps, and carefully constructed comparisons come in. Not to make the universe small, but to make it navigable. These tools do not reduce the immensity, they make it mentally passable. But even with these tools, there is a point where the scale breaks. Galfard describes it as a moment of saturation. The brain can keep hearing words, but it stops generating clear images. The distance becomes purely symbolic. We know it is large, but we can no longer imagine how much. This point is not a failure, it is a limit. Recognizing it is part of understanding the universe honestly. Science does not promise comfort, it promises coherence. Another important cognitive limitation is our relationship with time. We are accustomed to thinking in years, decades, perhaps centuries. Beyond that, time becomes abstract. When we combine stellar distances with travel or evolution times, the brain disconnects even more. Millions of years sound the same as billions. Both are outside human experience. Bokeh shows that this difficulty is double. We do not understand great distances well, nor do we understand great lengths of time well, and in the universe, both always go together. Every attempt to imagine one drags the other. Galfard emphasizes that this combination is especially challenging. Distance and time reinforce each other in their strangeness. The further away something is, the older what we see is. This breaks the intuition of the present and adds an additional layer of abstraction. Our brain seeks simultaneity, continuity, proximity. The universe offers asynchrony, fragmentation, and separation. The clash is inevitable. That is why, when we talk about galaxies, stars, or stellar travel, we usually fall into extreme simplifications. We compress distances. We speed up times. We make everything happen faster and closer than it really is, not out of ignorance, but out of psychological necessity. Bokeh insists that this tendency should not be seen as a moral error, but as a reflection of our mental architecture. The brain prioritizes survival over cosmic fidelity. Understanding the universe requires going against that priority. Here, a key point appears. Understanding does not always mean imagining. We can conceptually understand something without being able to visualize it completely. The universe demands this type of abstract comprehension. It asks us to accept truths that we cannot see with the mind. Galfard proposes that this effort has a profound value. By confronting scales that break our intuition, we expand the limits of what it means to think. We do not dominate the universe, but we broaden our capacity to situate ourselves within it. Metaphors, then, are not traps, but bridges. They do not replace reality, but they allow us to approach it without falling into total incomprehension. The problem arises when we forget they are bridges and start treating them as the destination. Bokeh shows that a good metaphor does not eliminate the strangeness, it only makes it tolerable. A bad metaphor, on the other hand, gives a false sense of comprehension. The challenge is to use images that keep the sense of scale alive, not that annul it. Galfard insists that we must accept a certain permanent discomfort when thinking about the cosmos. If everything feels comfortable, we are likely simplifying too much. The universe is not intuitive, and that is not a flaw in the universe. This recognition has a liberating effect. It allows us to stop demanding total comprehension from ourselves and start valuing partial, honest comprehension, aware of its limits. We do not need to feel every kilometer of interstellar space to understand its meaning. The human brain is not built to understand these distances, but it is built to adapt, learn, and construct conceptual tools. That is our advantage. We cannot change our biology, but we can extend it with ideas. In that sense, thinking about the universe is an act of cooperation between what we are and what we can come to understand. It is not about forcing the brain to be something it is not, but about accompanying it, little by little, toward territories that were never part of its original design. Accepting that cosmic scales break our intuition does not diminish us. It situates us. It reminds us that we are finite creatures trying to understand a reality that was not made to be intuitive, but that, even so, allows itself to be explored. And perhaps therein lies one of the deepest lessons of the cosmos. Not everything can be naturally understood, but everything can be thought about with humility, patience, and wonder. Truly accepting the distance between the stars is not just learning a new fact. It is not memorizing figures or getting used to words like light years or galaxies. It is a much deeper change. It is a silent readjustment of the way we situate ourselves in reality. Something shifts within us when we stop resisting the idea that the universe is not made to our scale. For a long time, even after knowing stellar distances in scientific terms, we continue to live mentally in a reduced cosmos. A universe where the stars were far, yes, but not radically separated. Where space was large, but not dominant. Where the sky was still, deep down, a nearby stage. Accepting the true distance means giving up that comfort. The first thing that changes is the notion of centrality. We not only cease to be the physical center of the universe, something that had already happened, but we cease to be the psychological center. We understand that we do not occupy a privileged position, either by proximity or spatial relevance. We are one more point, in one more region, in an immense structure where most things do not take us into account. This displacement is not humiliating, it is disorienting. It forces us to redefine what it means to matter. If we are not important because of our position, then why are we? The answer can no longer rely on the geography of the cosmos, but on something else. Accepting the distance between the stars shows us that the universe is not built for constant interaction. It does not favor fast encounters, immediate communication, or direct reciprocity. It favors separation, autonomy, distant coexistence. This changes our image of the cosmos as a connected place. It is connected, yes, but slowly, fragilely, profoundly mediated by time. This acceptance also transforms our relationship with the idea of travel. Travel ceases to be synonymous with moving fast and begins to mean traversing durations. We understand that going from one place to another is not just a matter of space, but of lived time, of inevitable transformation. The cosmos does not reward haste. It rewards persistence. Another important change occurs in our relationship with expectation. We live in a culture accustomed to immediacy, quick access, and instant response. The universe, on the other hand, teaches us that some realities are not available now, that knowledge arrives late, that information needs to travel, that waiting is not a flaw, but a structural condition. Accepting the true distance between the stars implies accepting that the universe does not answer our questions in real time. We observe what was, we infer what is, and we never have direct access to the distant present. This limitation redefines what we understand by certainty. Knowledge ceases to be immediate and becomes always provisional, contextual, dependent on the information's travel time. This change also affects our relationship with the night sky. It is no longer just something beautiful or inspiring. It becomes a map of extreme separations. Every point of light ceases to be a nearby presence and becomes a remote signal. Looking at the sky becomes an exercise in simultaneous spatial and temporal awareness. By accepting the real distance, the illusion of immediate cosmic community disappears. The idea that stars form an accessible neighborhood dissolves. We understand that even within the same galaxy, separation is the norm, that sharing a structure does not imply closeness, that coexisting does not imply interacting. This recognition also changes our perception of solitude. Solitude ceases to be only an emotional experience and becomes a geometric characteristic of the universe. We are not alone because company is lacking, but because space imposes separation. Cosmic solitude is not a judgment, it is a consequence of scale. However, this solitude is not absolute. It is nuanced by light. Although we are separated by enormous distances, we continue to receive signals. Not current signals, but real signals. The connection exists, but it is slow, indirect, fragmented. Accepting the distance does not eliminate the relationship with the cosmos. It redefines it. Another profound change occurs in our relationship with historical time. When we understand that the stars are so far away, we understand that our history is extremely local, that human events, however significant they may be to us, occupy a minuscule fraction of cosmic time. This does not diminish their value, but it situates them. Accepting this temporal disproportion frees us from an unfair expectation that the universe should revolve around our events. The cosmos does not react to our wars, nor our discoveries, nor our celebrations. It continues its process indifferently, not out of disdain, but because of scale. This change in perspective also alters our relationship with the future. The future ceases to be a nearby space that we can plan precisely and becomes an open, slow, uncertain extension. We understand that any truly cosmic project exceeds a human lifetime. That thinking about stars means thinking in terms of generations. Accepting the real distance between the stars forces us to think in terms of continuity, not immediate achievement. Importance ceases to be in arriving and shifts to transmitting, preserving, continuing. The universe does not favor quick results, but long processes. This recognition also redefines the idea of progress. Progress is no longer about rapidly expanding through the cosmos, but about understanding it better. The true advance is not in reducing impossible physical distances, but in expanding our comprehension of them. The mind becomes the main vehicle for exploration. Our real position in the cosmos, seen from this perspective, is paradoxical. We are physically significant, but cognitively extraordinary. We occupy an irrelevant region of space, but we are capable of thinking about scales that completely surpass us. We are not great because of where we are, but because of what we can understand. Accepting this changes the way we measure value. Value ceases to depend on physical magnitude and begins to depend on the capacity for consciousness. In an immense and silent universe, consciousness becomes a rare, precious, improbable phenomenon. This change also introduces a new form of responsibility. If we are capable of understanding the real scale of the cosmos, then we are also responsible for how we use that knowledge. Not to feel small or insignificant, but to act with greater humility and perspective. Accepting the distance between the stars reduces artificial urgency. It reminds us that not everything has to happen quickly, that haste is not a natural law, that the universe operates on scales where patience is the norm. This lesson can be translated into our daily lives in unexpected ways. It also changes our relationship with silence. The universe is silent not because it is empty of meaning, but because it is full of space. Silence ceases to be absence and becomes context. Accepting the distance implies accepting that silence as an essential part of reality. When we truly integrate these ideas, something calms down. The anxiety to understand everything immediately softens. We understand that knowledge is a slow, fragmented, always incomplete process, and that ceases to be frustrating and becomes liberating. Our real position in the cosmos is not that of protagonists, nor that of privileged spectators. It is that of patient interpreters, beings who receive fragments of the past in the form of light and construct with them a coherent image of the whole, knowing it will never be complete. Accepting the true distance between the stars does not move us away from the universe. It places us, for the first time, in an honest relationship with it. A relationship based not on illusions of closeness, but on respect for the immensity. And from that honesty arises a deeper form of wonder, not the naive wonder of what seems close, but the mature wonder of what we know is incredibly far away and even so manages to speak to us. In that final recognition, we understand that our real position in the cosmos is not a point in space, but a point of view, a place from which, despite the distance, the universe can be thought about, understood, and, in some way, accompanied in its silence. There is a moment, almost imperceptible, when understanding distance ceases to be an intellectual exercise and becomes an inner experience. It does not happen when we memorize figures or when we manage to imagine a greater sum. It happens when we stop trying to domesticate the universe and start simply listening to it. Distance, then, is no longer an obstacle. It is a message. Understanding how far away the stars are does not make us astronomy experts. It makes us aware of our limits. And that awareness is not a defeat. It is a form of honesty. For much of our history, we lived with the feeling that the world should adjust to our measure, that the distant should be conquerable, that the unknown should become familiar. Cosmic distance breaks that expectation without violence, only with evidence. Accepting the true separation between the stars is accepting that not everything is within reach, and that is okay. The universe does not owe us closeness. It is not incomplete because we cannot traverse it. It does not fail because we cannot touch it. It operates on a scale that does not take into account our desires or our urgencies, and recognizing it does not diminish us. It situates us. This acceptance introduces a different form of humility, not the humility that comes from feeling insignificant, but the one that arises from understanding that we are part of something that does not revolve around us. A quiet humility without drama that does not seek to disappear, but to coexist. Distance teaches us that reality is not made to be comfortable. It is made to be coherent with itself. The universe is not organized to facilitate our comprehension. It is we who must learn to approach it without demanding that it adapt to our mental scale. In that learning, something softens. The need for control dissolves. The anxiety to dominate everything loses strength. We understand that there is a profound beauty in what we cannot encompass, that the unattainable is not a threat, but an invitation to think more carefully. The distance between the stars also reminds us that not every bond requires physical closeness. Although we are separated by abysses of space, we are still connected by light, by information, by the shared history of the cosmos. The connection does not disappear. It transforms. This recognition changes our relationship with the idea of importance. To matter no longer means to be near the center or to occupy a lot of space. To matter can mean to be conscious, to be capable of understanding, of questioning, of reflecting. In an immense and silent universe, consciousness is a rare event. Understanding distance as a form of humility frees us from useless comparisons. It ceases to make sense to measure ourselves against the size of the universe. Scale is not a competition. The cosmos does not challenge us to be big. It invites us to be lucid. In that sense, the true lesson of distance is not scientific, but human. It teaches us to inhabit the world without demanding a leading role, to accept that not everything is made for us, but that we can still participate, observe, and learn. Distance also introduces patience. It shows us that some things are not resolved quickly, that some processes require times that exceed a lifetime. This patience is not resignation, it is perspective. It reminds us that being part of something vast implies accepting rhythms that we do not control. In the end, understanding the distance between the stars does not change the universe. It changes us. It changes the way we look at the sky, but also the way we look at our own life. It helps us distinguish between the urgent and the important, between the immediate and the essential. When we look up knowing how far everything is, the sky does not become colder. It becomes more honest. We no longer project our expectations of closeness onto it. We accept it as it is, immense, silent, distant, and, precisely because of that, profoundly revealing. The humility born of this understanding does not put us out. It centers us. It reminds us that we are small in size, but not in capacity for wonder, that we do not dominate the cosmos, but we can understand it enough to feel part of it. And perhaps that is the true conclusion of this journey. not the feeling of having arrived at a definitive answer, but the tranquility of having found a just position, one from which the universe does not need to be reduced or conquered or fully explained to be respected. Understanding the distance between the stars is, ultimately, learning to be in our place, and from there, looking up with less haste, fewer expectations, and more depth.